Welcome, I'm Bill Wake. We're here working on a calculator that can help kilt makers, and one of the characteristics is at least some of them work with yard, feet, and inches, so we're trying to accommodate those. And right now we're focused on memory keys, so memory recall, memory clear, memory plus, memory minus. All right, that was last week, so I messed up something on the tests. I think they're working okay now. No, something's weird. All right, we did leave off with a failing test. But let's see. I don't know. I tried deleting the test plan and recreating it. But let me try deleting this completely. See if the leftover plan was causing some troubles. No. Okay. Let's go here. Kilt calc test. Test plan Kilt calc. Let's manage test plans. I'm going to delete this. Close. I'm going to... No, why is that still there? Okay, that all seems okay. I don't know that any of this makes a difference. All right, no test plan. Let's make a new test plan. I'll call it a little different name just so we can make sure it's its own thing. All right, we'll add the tests. They look like they're there. All right, let's run them. Okay. Now it is running them. I don't know. I think we get that same error stuff. Yeah, let's quit Xcode. Even quitting. Okay, I hate to do it this way, but okay, that's not the one I wanted. See if we can get these back. I assume it must be, but like, why is that there? This one, let's delete this one too. I mean, if I'm here, Kilt calc unit tests, that sounds right. Let's run tests. Okay, I think that's, yeah, good point. Where's tests? Those failing tests are probably down in here, yeah. Okay. Let's, there's one failing test. I'm going to comment it out. Make sure everything's green. Yeah, I think it did. I'm just going to check this in because I've mucked with the project structure. So assuming this is green. And I probably will try a rebuild just to make sure. Gotta make sure it works from there. Now why it's so slow, that's another question. There we go. Okay, so product, clean test. and build, run the tests. Okay, and commit fix error and test plan. I think that's good enough for now. All right, now let's get back to our red test. Okay, so our problem is MR doesn't really do anything. So we saved, well, we added 9 to memory and then tried to call it back. Well, memory should be 9, but I think this should be 36, right? Yeah. So we're getting the 9M plus. Oh, yeah, no, this is a little confusing. So M plus is sort of like an enter or an equals that says like your expression's done. So then we're entering 18 plus the 9. All right. And we're failing because MR doesn't do anything. All right, let's go back. Okay, I'm gonna start back at keypad. I believe everything's hooked up. So yes, MR is memory recall, M plus is memory add, and then let's go find who uses these. Oh, and I think we were hitting the issue of 0 plus 0 kind of things. Well, I guess we're not yet because inches versus non-inches, we don't really mix them. Okay, so calculator. Oh, MR not. Okay, let's run the one failing test. We should see some not implemented in here. Yeah. MR not implemented, an expression not done. Okay, now MR not implemented. That was in here. Nope. Here. MR not implemented. Why didn't we get M plus not implemented? Okay, because we theoretically did implement it. Okay. So this acts like it calls equals. It stores the value in memory. That's fine, but MR does not do anything yet. Okay. Now, what I want to do is pull back that value that's in memory at this point. Let's just make a little method for it. Okay. It doesn't change memory, but what we'd like to do is get the value from memory. And we want to feed it into our input. So if you had 9 in memory and did memory recall, we want to pull back 9 and shove it into the input stream. Okay, so let's see. So I think that means we're going to need to format things. Well, yeah, like that. Yeah, that's right. We could convert a special token. I do kind of like that approach. It puts a little more work on the calculator to track one more thing, but yeah, let's do that. Because then when you hit delete, to undo it, it undoes the whole thing. Okay, so I do like that better. All right, so let's. I don't know if it's where is that thing? Entry. So I guess I'm just going to call it value. And it takes a value. Okay. Now everybody's going to complain. Well, 2 or 3 places. Okay, calculator. Down here. All right. I'll stick it after digit. Okay. Entry needs a way to print it. Oh, this was entry. Okay. Where's calculator? Okay. Oops. Okay, same test should be failing. Yep. Okay. So now let's deal with input. Okay, so it's always just adding entries. So yeah, maybe we should dig in a level, huh? I don't know if we have a lot of tests testing that sort of thing. It's not that we couldn't. Yeah, I think a very simple test for that would be called for. Units and operations. Yeah, let's stick it right there. Okay, and I'm just going to write this one directly with entries. Okay, so let v equals dot, well, entry dot value, value dot numbers, fine. Okay. I don't think I have a calculator. Oh, I do. And well, it should be 33. Well, I think that should do it. Okay, so calculator. Value. Okay. Really, editor? Come on. All right. So, well, I think it's just input.add entry there, and then the actual evaluation is an expression. Okay, evaluate. Here's our case. Okay, dash unit digit. All right, case dot value, let value. Is that right? I think that should do it. Here we have to accumulate the pending values, and then finally at the end we got a operand that will turn it into a real value and push it. This one directly already is a value, and we just push it. I think that should be okay, and I think that should do the job. Well, I think something has gone wrong. Huh. Okay, I'm gonna pull this in here. Oh, whoops, what's going on there? Oh. Oh. Something seems odd. All right, let's make sure we're getting to where we want to get. All right, so calculator.value. Maybe I haven't pushed something on the stack. Okay, no. We add that to the input stream, which is a list of values. And so that's the enter. When I hit equals, we'll do this. Expression inputs evaluate, okay. And history append, right, okay. Well, I guess evaluate. Let's stop here. Okay, so let's print input. It should just be value and equals. Oh, just value. Okay. Double check equals. Oh, it does not push itself. Okay, fine. So we should be able to go over that. Last is binary operator, no. Input add ending, okay. Start back, enter equals next entry. Okay, so we should end up in our value case. It's the only thing there. Okay. Step over, let's look at operands. Oh, I didn't call next entry, did I? Is that going to matter? Operands is empty. Oh yeah, I think everybody's supposed to do that, or they'll just be an infinite loop, apparently. All right, now this doesn't have to. I mean, he's done it along the way, so let's. Now I'm pretty sure I've not moved forward through my input stream. Okay, let's run that as a test. We'll get rid of the breakpoint. Well, continue. Okay. Right, I think our test value passed its test now. Okay. All right, so add entry dot value. Oh, well, let me comment out that one. I don't mind stacking like this, so I've got a failing test. I bite off a smaller bit and pass it, but I do want to check in green, so we'll just make sure that's all totally green. Okay. So add entry dot value, holding a value to push directly onto the operand stack. Right. I don't know what that is. Okay. Now I think I don't know if I'll say evaluates to itself. Okay. Now in entry, I think these descriptions, they don't really show up, I don't think. Let's see where this is accessed. They're more of a debugging thing, I thought, but okay. Enter equals evaluate. Oh no, that's entries operand. Oh, okay. Kind of a easy way to get it. Mostly these are only coming in for the digits, units, and slashes, so they don't show up in other ones. Really, nobody else uses description, I think. I guess the better way is to do it. I should find usages of this. Okay, we define it, we use it, and then input buffer to string. I don't know how much we use that. Well, It's a bit. Okay, let's see. I think we'll see this. If it's not a happy thing, we'll see it. Let's make sure that's green. Okay. Let's make another move on this. Okay. Can't end with an operator. Yep. All right. So memory recall. Let's see if we're ready to do that. Memory recall. Okay. So this should. Well, I think it should just do input dot add value of memory. Okay, because our memory is already a value. So that should pull it in. Okay. So we'll take the current value in memory, we'll add it into our budding expression, the expression we're building up, and that'll be there when evaluation comes through. All right, now I think this will pass. I also think it won't look good. All right, so I'll do a run to demonstrate that. Okay, what I think is going to happen. Okay, so we'll do 44 memory plus. No, I don't know if that should still be there like that. Let's do 22 equals, and then do 12, or how about 33 plus memory recall. Yeah, we don't have a good display of that. Okay, so let's, where's the right place to do that? Memory recall equals, well, I think there's a simpler case. Yeah, I think along the way it looked good. 7 memory plus, and then do memory recall. And we would expect memory to be 7 and display to be 7. And we'll say we should show the value. Okay. And I'm thinking this will fail. Well, not quite that fast. I think it'll come back with the word value based on what we just saw. Okay, what do I know? Where is that coming? Okay, let's see what that does. Because we saw it fail, so I'm hopeful. 7, and then MR looks like value to me. Let's see, what are we getting? This is display. No, it's calc.result. And that's, let's do calc.display, right? Because that knows when it's looking at input or the result. Yeah, so I think our test should be a little different. Okay. No. Value formatter.format. This is already formatted. Didn't double check the other tests would be correct with it, but no. Okay, is this value? Here we go. All right. Oh, that was entry. Huh. Now value, it doesn't seem right. Entry should have to know the value formatter. Okay, let's see where we go. So expression evaluate is happy with it because it's a literal value. I think it's calculator that's the one that's fallen apart a little. And we do input dot add, and then this list of terms that sort of we talked about it as tokens almost in a compiler sense. We've got, a digit operation or a digit followed by an operator, followed by another digit, followed by an operator, followed by memory recall, which is a value. Okay. So I know I can muck with entry, but the value here, well, I should probably, I'm not sure custom string convertible is really the right attitude, honestly. Most of these don't show up. Well, no, some of these won't show up. Okay, so ending, we never expect to show that. Digits we show, operators we do show. Unit, yeah. I think we've got to give this thing a formatter. And so he's not really going to be a var anymore, and he's not going to be custom string convertible. Yeah. So that test wasn't testing display. It was testing the actual last computed result. Yeah. So calculator, like who knows the formatter, right? It's this thing. Value formatter dot format with imperial formatter. Actually, it's this thing that's kind of the controlling thing, because if you're displaying yard feet or inches versus potentially other things, this one is not. That's the loose cannon. They can set that one to whatever they want. But when we ask for the description, which I think we do in here. No. And that was toString. Input toString. Okay, well, that's probably right. There's your descriptions. Okay, so have no tests for units. No, we don't. And I was putting that off intentionally. Because we know there's an issue there, because 0 plus 3 inches should be okay to be 3 inches, but we know we don't have that in our language or our value support yet. We will we will have to. Let's say I think toString needing a formatter seems okay to me. So let's let's make description take a formatter. It only needs it for value. That really is too bad. I mean, I could store the string. I could let whoever creates the value could store it. They could do this kind of thing to it and get the string value for it. I might say that's all right. But yeah, I think we'll do that. Okay, so value, let's give it the value, well, sorry, let's do this. Let's start up here. So value is going to take the value and a string, and we'll reference it down here. Let description, maybe an okay word. All right, we are going to implement it, and we're just going to return description. Okay, so create it with the description. Can ignore this one. Okay. Now we should get a complaint or two about creating value. Value memory. Okay, and his description. Well, you get it like this. But this is memory rather than the other. Memory and the formatted value. And it's going to complain if I... Okay, and there should be one more. That one's okay. There it is. Actually, there should be one in the test too. Value, and ignore the description here and push that. Okay, and there should still be a test. All right. Next argument. Oops. Okay, so entry tracks that value. All right, so make value show during show in expression by including a string description in the entry. Yeah, we should just define our own whole formatter. Let me not forget that. Oh, I'm not being very complete here. Hey, I added somebody's request the other day. Forgot the name, I'm sorry. But I did add bang today, so it prints out what we're up to. Okay. I guess I have to remember to update that every few days because that'll cover us there. But I'll do that. And if there are others I should have, let me know. Somebody suggested hi, or in other places I saw people using hi. They would get the same thing. So the first time they spoke up and said hi, it gives them a little background. So I probably should do that. Okay. So down here, we're at CALC 2320. 626. And this is memory keys. That. And now, well, MR is kind of in progress. I guess that's still true. All right, let's go back to those tests. At the bottom. This is good. Okay, so we'll just run it. All right, so 44 memory plus 12 plus 1 plus 3 equals memory plus, memory recall plus 6 equals. Okay. Now, and then memory recall again should get 44 still. All right. I think that feature is done. So this is memory recall for integers. All right. And then we need MR with units. All right. But if you do 4 inches, well, whatever, plus memory recall equals, yeah, that's okay. So something's funny. I think we're back to this issue of how do you know when it's safe to type a particular key. Yeah, so it should be an error. So what I did was I hit memory recall, and instead of it saying, okay, you just finished an operand blowing up, okay, that's fine. If I hit type 44, I don't have a thing to say this is a number. Well, let's say yards for this. That would get that complaint. What we had was 44. Well, sorry, let me clear that. Memory recall, and now I'm typing a number next to it. It looks like it's the same number, but really that 44 is the dot value we just had, and now it's a dot value followed by a digit. Inches equals, like, whoa. And the message, yeah, I mean, this is saying it thinks it's unbalanced parentheses because it gets to the end after it does its computation and there's still stuff on the stack. And normally that can only happen from parentheses. But we definitely have a test coming here for this. And this test didn't even involve inches, right? It happens the same way. Okay, so memory recall 4 equals still has that error. So memory recall, let's make sure. If you do 9, put it in memory, and then memory recall 7, I guess equals. We expect the memory to have 9, and we expect an error. And I think the error should be, well, I think the error should be as if you typed, let's say you type, well, maybe it's not the same. I was going to say if you type 7 inches, 7 feet, that's legit. But somehow if you put 2, I mean, we're very flexible in that. If you do 7 feet, 7 yards, 8 feet, 3 inches, 7 yards, 2 feet, 2 inches, you can keep adding those terms on. But the error you should get is, I think, maybe it's something about an operator or yeah, so I think even worse, let's do memory recall, memory recall, memory recall. Like, what would you call that? I wouldn't call it, well, certainly not unbalanced parentheses. It also makes me wonder, like, if should I even put a space in there? I mean, it's let's say, should I do that? Would that be better? Let's see if we add that space, if it makes an improvement. It's entry. No, it's the calculator value. Entry. Where's the entry created though? Value. No matter. Well. Space. 1, 2, 2. Okay. Yeah, and I don't want that actually. I mean, I think that's just kind of wrong. That you calculated some value. I don't know. It would be explainable. Did I run tests again? Oh, that was not right. Memory recall input.add value. Maybe I'm doing a trim somewhere. That should be the place that creates it. I believe I'm putting a space in. Okay, let's run it. For memory plus, clear, memory recall, no space. Oh, there it is. Okay. Why that? It's, I don't know if it's there, but trimmed. I guess that's display. Yeah, it trims. Okay. So my test is not right then. I don't think trimmed looks bad. I just want it there when I do 2 in a row. So let's do 2 in a row. So add 7 to memory, hit memory recall, memory recall. I want to see the space in there. Is that going to help? Well, I think this will pass. Yeah, I mean, I think it's definitely on the list to disable buttons. But until we do that, I want it to, I mean, that message was unbalanced parentheses is completely confusing, so I don't want to do that. All right, test did pass now. But I still have another scenario in mind that I think is not ideal. So let's do 22, memory plus. Okay, now if you do memory recall, memory recall, memory recall, that if the message said something about, can't have 2 operands in a row, I would be okay with it. But what I think is funny is I can do 11 yards, memory recall, inches. I don't know. That doesn't sound so bad to me. But here you are. So Does that mean we've gone down a bad path? Or is this just the way it is? Okay. This one. Right. Okay, let's get the one that shows an error. Oh, I think I have one. Yeah, I mean, does that seem like it's the right thing? It seems off to me. If you hit memory, I mean, if you calculate some stuff, you forgot to put the inches on, so you want a memory recall, say inches, that seems okay. I can understand the restriction too, that you're in the middle of some value and you can't put it in. So, gosh, I don't know. That may be suggesting if we had gone and done it more like convert it to, it had to be dot digit and then soon dot unit and slash, we would get them in. Well, value seems okay. I guess I'm okay with a restriction, but I want to make sure if you do this, it complains. I want it to say, I don't know, operands. How about can't put two operands in a row? Okay. Yeah, well, it's easy for digits, but then when we have the units, I'm going to have to parse the string or interpret it. I don't know. Value counts inches as doubles. So maybe that's not so bad. It knows. We could always just say inches and never deal with yards and all that stuff. Excuse me, just say, the calculated value is returned as inches. And then we would put the inch entry in there. Yeah, it's hard to know the right thing. But, okay, I am saying I'm making a call on this one. This looks illegal. The spacing will kind of hint that something's funny, and we'll go from there. Okay, now this unbalanced parentheses, yeah. Okay. So where will this show up? R7. Well, okay. We've done it till now, right? We check the previous thing. Which, if we did the illegal button thing, this wouldn't be needed. Okay. So, okay, previous entry is really just to cover, if you say 7 plus or minus 4, it says, oh, that's really 74 plus or minus. It's kind of a syntax error prevention thing. But, okay, otherwise it just pushes the operand. So I guess we still have expression is dealing with that. Operands push. Let's see, binary. Now maybe this. So, okay. Sorry, I missed a couple of messages. Value can't be combined with unit. Well, it is. Values can be simple numbers or units. They're just stored as inches. So with the way we're doing it with the value formatter, it follows, if you said show yard, feet, inches, we would show 3 yards, 2 inches, what is that, 110 inches. Or if we did it as simply, we would just say 110 inches. I guess that's okay. Gosh, I don't know. So the question to me is how, this is kind of a syntax error question. Like if you have digits followed by digits, well, oh no, maybe the slash case is the thing that demonstrates the problem. Okay, so digits do their work. Yeah, so normally if you push an operand, if you entered more digits, it would form that all into one big operand because it gathers those in the expression here. So if a sequence of digits, units, or slashes comes in, it gathers that in depending, and then all those get turned into one operand and pushed. And so if you ever try to have 2 operands in a row, you can't do it because you don't have a space character or a separator or something. If you put more digits, it just adds them to the list of digits. But now you can get 2 operands in a row because you've got memory recalled values and digits or units or slashes. Now it doesn't know those here. I mean, you probably could check it. Okay, while the entry is an operand, pull them in. Okay. I mean, I suppose here you could do some sort of tracking to know that the last thing was an operand, that you had previously pushed an operand. But anyway, it gets unbalanced because you push 2 operands. Normally you'd have to push operand, some sort of operator, and then another operand. But we're letting you push multiple operands with no operators. And when it finishes the expression, it just evaluates according to those stacks. So which is driven more by the operators. So you have a stack of 2 operands and no operators. Normally we would say take the top operand, and that's the current value. But then you get outside the stack. At the end, we look and say, did you use up all the operands? And if the answer is no, then somehow you got more operands on the list. Okay, so now I don't know if it may be that not both of these are unbalanced parentheses. No, I think it's the expression evaluation that I don't even think it gets confused in a way. Even like a traditional language, like if you said 7 space 2 plus 3 equals, or some x equals 7 space plus 2. Sorry, x equals 7 space 2. That would get treated as 2 separate numbers. And you'd probably get a message. I don't know. Let's try it actually. Let x equal 7 2. Okay, and we should get a syntax error there. Consecutive statements on a line. So it's not even a very nice message. You can tell it's very confused because it thinks this is the end of an expression. If it had an operator, oh yeah, there's more expression coming. But this one, I think it interprets this as this, or which is the same as this, which the first line looks good and the second line looks like, what are you doing? That's just an integer sitting on a line, nothing's happening to it. So it's sort of the same thing here in Swift language. It's just a question of how do you recognize the problem? Now, I think something's funny here, right? Oh, index less than that. Okay, no, I guess that's not. Right. At the end, we evaluate the leftover bits of expressions, I guess. And so evaluate at least should consume all the operators. Okay, so we should have operands is empty at the end of this under normal circumstances. If we do precedence at least one, because the way we set the precedence up, it doesn't matter. So theoretically, this one will not happen. I think that the actual error is coming from this one. It would indicate an unbalanced problem too, but I think they're more likely to attempt to pop and find the stack empty, which maybe is more like this error. Okay, so if you did, let's see, what does left parenthesis do? Does he just push himself? Yeah, he pushes a left parend. Okay, so what does the right parend do? It evaluates. And if this... Yeah, if there are no more operators... Okay. The problem is this condition can be true either because of unbalanced parentheses or two consecutive values. That's kind of my bottom line. Now this one I don't think can be that. I'm not 100% sure. I'm not 100% sure you can make this happen without parentheses. Parentheses got put in with 0, so they will not get evaluated. Yeah, I guess maybe if you had more left parens, you could trigger this. Let's just muck with this message. Excuse me, and make sure the test is showing this one that I expect it to be. Yeah. Okay, that is the place coming out with that message. And then this one probably is a parenthesis problem that expects, it expects that same message. It gets the XX. Okay, so this is kind of a failure of unexpected or too many right parens. Let's see, do we have a case with too many left parens? Let's add that. That seems to be a hole. Okay. And I'll just leave it incorrect. Make sure which message we're getting. Okay, and this is getting, so this, I think that's the way to understand it. This one is too many left parentheses, this one's too many right parentheses, or you've shoved two operands in a row. Yeah, it's missing operators. I think the message should be unbalanced parentheses or missing operators. That, you're right, that's probably the real way to say that. Because if you, no, wait, can I say it even better? Missing right parend or operators, would that be a good message. I could still say error on the front. I don't think that would hurt. I don't know if I've totally been consistent, but okay. Let's make sure that the places that fail this test are, in fact, missing right parens. Okay, so yeah, this one should just be unbalanced parentheses because it's the left parent case. Actually, it should probably be extra right parentheses. That's the real error there. Okay, and that's the one we expect here. Well, it's not. Let's go the other way. We're missing these. Okay. And, oh gosh. And it's really unbalanced or missing right parenthesis. What message did I say? No, I think unbalanced parentheses is going to have to be what we say, because there's just too many ways that they're missing isn't quite right, because we could have, like the second case 185, we in some sense we're balanced, but they're not really. Okay. Unbalanced parentheses or missing operators. And this is really usually from unbalanced parentheses. And I don't feel like I have to be super exact, but enough to make you look at the expression and get some clue of what we think is wrong. And then down here, error, unbalanced parentheses or missing operator. Okay. $183. There's one right parent too many. Yeah. Okay, and then fix the messages to match. That one's fine. Error unbalanced parentheses. Well, that's acceptable there. That is true. Okay. This one, error unbalanced parentheses or missing operators. Yep. All right. Detect MR followed by number missing operator. Adjust error messages around parentheses. C's and operators. Okay. Now, another thing that would be good if we did the thing to prevent you from just even hitting the button in the first place, a lot of some of this stuff we would have detected before you ever got here, so we wouldn't really have to worry that this case happened. The only error I think we would have to worry about, the actual computations on the binary operator could produce an error value, but the way we do them, we bubble them up all the time with the computation. So it would be from the numeric problem, it wouldn't be a grammar problem. Okay. All right. So let's see. What do we got? More for integers. Right. And I want the corresponding other case. Let's do 7MR. Yeah. Well, yeah. So we could do that outside, like, well, in here, once we've got, like, once they hit equals, we could run that checker over our input and check a number of these problems. And maybe that would be a step forward. But I'm kind of putting it off because I do like the idea of deactivating buttons that would create syntax errors. And I don't know, it would be kind of re-implementing this stuff in a pre-processor pass. But the advantage would be, theoretically, these wouldn't happen and so on. So that might be a thing to do. Maybe that's an intermediate step. It would simplify the expression evaluation at the expense of creating the routine like you outline here. It could certainly detect the two operands in a row and all that kind of stuff. You know, operators without operands and stuff like that. So that would pull it out a level, and that would sort of be, again, kind of, you know, some compilers have done that stuff in multiple passes. You know, tokenize it, detect any errors along the way there, then do a syntax check, and then you can trust the grammar to just do its thing. And actually, early compilers had a tendency to, they would not recognize syntax errors, and then if it worked in the evaluation routine, you wouldn't know that you had a syntax error. So, you know, it's definitely a step forward from there. All right, so let's see. That last test was, I want the same thing if you go the opposite way. Yeah, so we're putting the number and then the memory call as opposed to the other way around. Okay. In principle, it's the same kind of error. It's two operands in a row, but which kind of operand first? All that's different. Okay, good. Check another MR error case. All right, I think we're done with the first one. And I'd say we're due for a break. So let's take this, and then we'll work with this one. And actually, we know we have a step to do first, which is handle zero, handle zero mixed with units. Okay, that'll get us enough to get there. Because normally we default to the initial display being 0, and the 0 mixed with units is going to have a case where we have 0 plus 7 inches, say, and it would get confused by that. So assuming our memory is, the other way we could deal with it is make our memory more of a conditional value and let it be nil at start, and then, you know, but then you got to worry about all that. So, yeah, one way or the other, we'll have to deal with this. All right, so let's take that break, 3 or 4 minutes, and come back, and we'll hopefully finish memory recall, I think. All right, see you in a few. Okay, welcome back. Yeah, let's add that. M plus or M minus shouldn't mix numbers and units. Okay. All right, so let's see. The value. Yeah, I think this is a value test. Somewhere we check. Okay, there's errors. Let's go to the top. Number minus number, inches minus inches. Errors always turn into errors. Number times number, number times inches, those are okay. Inches times inches is error. All right. Number divided by number. Okay. So I think what we're trying to say is, well, error in anything being error, that's okay. Number times number. Okay, inches times inches is error. I'll say except 0. 0. Okay, so in this case, equal. If you take value dot inches 0 times, well, what do we want to come out? I don't know. It should either be this or value dot double 0, or what do we call it? Number? Number. So probably, this is so hard. I mean, in a mathematical sense, right, it probably should be just plain 0. Yeah, no units. It's weird because it throws off like dimensional analysis kind of stuff. You know, inches plus inches equals inches. Okay, that one's okay. Yeah, maybe this is okay. I mean, you had to special case it, so there's no way around that. And then we can do the flip. Well, this is inches times value dot inches 0. Inches 3 dot times value dot inches 0 should also be 0. Doesn't matter whether it's on the left or the right. Okay. I think that is true. And in this one, I think we're just kind of like letting a marginal case. Maybe it's just 0 is just special. But, you know, something that would be an error normally, because we don't do square inches, you get to squeak out because you did multiply a 0 in there. Okay, but it's a starting point. And this is operator by operator because it's real specific to times. Okay, can't handle square inches. All right, and let's go look at times. Okay, so number, inches. All right. So let's get the A and B here. All right. If A equals 0 or B equals 0, we're going to return dot number 0. I think I'm probably supposed to say A dot is 0. Okay, but error times anything is still error, so that's fine. Okay, I think that's going to do that. Okay, now the others are all defined. Okay, let's go look at plus. Number inches, error mixing them. Okay, so we'll have to break out that case with the same kind of thinking. I probably did plus first, didn't I? Number minus number. Well, we didn't really do plus. That's weird. I guess it probably got them covered by other cases, but let's number plus. Five plus 2 is 7. Well, I don't know. I think I'd be just as happy with one of these kind of tests. For this, let's just do plus. Input is AB 5, 2. No, it's got to be the value. I'm going to do input. Did I use EG down here? Value $0. Okay, so 5 plus 2 equals 7. If you did error A plus number, we expect the error back. And if you swap it, okay, and if they're both errors, we'll expect the first one. All right, plus minus needs 2 numbers or 2 units. Yeah, so the mixing, okay, so if you do number plus inches, we expect error. Let it tell me the exact message. It's fine. Okay, and then this one, inches plus number. Okay, let's make sure this test is approximating. Okay, those messages should be wrong, but I think the rest of it should be okay. All right. Error mixing inches and numbers. Okay, so that test should be good. Now we're going to put the 0 test in there. Okay. If you have number 0 plus inches, we expect the inches to just come back. Okay, and then similarly here, if you have inches 0 and 2, we expect the number to come back. Okay, and these 2 tests should fail. Oops. They'll get the error message when they really shouldn't. Okay. And value does the computation. All right, here's our error mixing. I'm going to split this case. Number inches. Inches number. Okay. So if I guess we gotta get the values. Let number A inches B. Okay, if A is 0, I probably need to cover one more case here. Let's add the test first. Okay, so this one is number plus inches, but let's make the inches be 0. Okay, so 6 plus 0 inches. And then, oh gosh, this last case. Okay, and then the corresponding ones. If inches is 2 and number is 0, expect inches. And then if they're both 0, four combinations. Okay. And I expect those last tests to fail as well. Okay. Okay. Now, if A is 0, so let's start with B. Okay. If the inches is 0, we're going to return self. Okay. Else, if A is 0, we're going to return other. All right. So let's make sure that works in the right situation. Otherwise, error. Okay. I think all three of those on the first one should pass now. Okay. Yes. Good. All right. And I'm doing B first because we want to get rid of inches if possible, because if they're both 0, we want the inches to be the number one. So self is the number. Okay. Now this one, same logic, I guess. Inches A, number B. If A is 0, return other. Else if B is 0, return self. Well, that is the same, isn't it? No, it's not. Because they happen in order. So if I did the first one with inches and the number is 0, if they're both 0, that would fail. But I can... Oh no, I can't even combine these, right? We tried that before too. Okay, I think this will pass as well. All right. Now we've got minus number, inches minus inches. Oh, we don't have minus. Well, these should fall out of plus. Number minus number. Well, we don't really have the error case covered, do we? Test minus with let me do it like this again. All right, example is a pair. I don't know if I can do this without first doing the other. Number 2. Expect number 3. And then we'll do e.g. assert equal. Zero dot minus $0 dot input dot 1 expect $0. Yeah, can't infer. Okay, that covers this case. All right. We're going to have some others. All right, so this one now is inches minus 2 inches expect inches 3. All right, so I have a missing case here. Okay. If I had number 5, number minus 5, whoops, let's make that inches. This creates trouble, but 5 inches plus negative 5 inches equals 0 inches equals 0. Okay, and we probably fail this one. We return inches, I expect. Really? Wait a minute. I'm not sure I believe that ran. Thank you. Okay. This one. So if a plus b is 0, return dot number 0. Otherwise. All right. You get more tests than you expect. All right, let's start getting the combinations here. Maybe I should take all these. Maybe I'll just take them all. And this is minus. Okay, so error minus error. Really? Why is that? Value.error. You're okay up here. Yeah, I just need to change the expected values for the most part. Consecutive statements on a line. I don't know what his problem is. E.g., did I bump in a parenthesis or something? 2, 1, 2, 1, 2, 1, 1. Consecutive statements on a line. Oh, I didn't say check. Okay, now 33. Okay, so error minus 2 is error. Number minus error is error. Well, I left out another set of cases, didn't I? My goodness. This should be inches. Inches. Okay, 5 minus 2 is 3. 50 inches minus 2 inches is 48. 5 minus 2 inches is an error. 0 minus 2 inches, expect minus 2 inches. 6 minus 0 is 6. 0 minus 0 is the number. Okay, 5 inches minus 2 is an error. 0 inches minus 2 is negative 2. 2 inches minus 0 is 2. 0 minus 0 is 0. Inches minus 0. And inches 5 minus 5 is 0. Okay. My expectation is this will pass. Just because we implemented negative with plus. Yeah. Okay. So let's error. Well, make sure number 0. Well, let's see. How do I want to say this? Check that zeros combine with numbers or inches properly. Plus and minus. Okay, these are taking longer to test than I expected. Okay, error times anything, yeah. Inches minus inches, we did this test up there. Okay, error times anything, that's fine. Number times number is fine. Number times inches. All right, let's add our error case. I don't have inches times number. Inches 0 times number 2 should be number 0. And the flip side of that should be inches 2 times value 0 should be number 0. Okay. Oh, these aren't EGs. Okay. Well, I don't think they have to be. Okay. Now, inches times inches. Okay, inches times inches with numbers. Okay. Right. And then I don't have inches times numbers, so let's try this one. Okay, so these should all be inches. Inches, inches, inches times number. Inches times number. Wait, something's funny. Maybe this thought it was doing both. Yeah, the first test was testing more. All right, number times inches or vice versa. Number times inches, inches times number, inches with 0. So let's do the numbers first. Inches. Well, let's do number 0 times inches 2 equals number 0. Okay, number times number. Should be one more case here. Number 2 times inches 0 should be 0. Okay. And I think the new one should fail. Wow. Hey, Xcode, come on. Well, those tests not running, I guess where Sign Xcode was losing a little bits of its mind. I know. Like, it's just multiplying by 0. Okay. Number 0 times 2 inches equals 0. 3 times 0 inches equals 0. 0 inches times that. Okay. So we got to test those multiplication cases. Okay. Errors get done. Number times number is not a problem. But if I think I did a mistake up top. Let's see. 0. If the inches is 0, then we want to return number 0. Else, if A is 0, right? If A is 0, it's 0. If B is 0, it's 0. Okay, so let's make sure that passes those 2 cases or 3 cases. Okay. Value test. Yeah, okay. And then we can simplify. If A is 0, or b is 0, return that. Okay, that's multiplication. And then this one, same thing. If I think it's literally the same thing. If a or b is 0, then the multiplication is nothing. Okay, and that, well, I wish I could, but unfortunately, because they have let clauses, it won't let me mix and match. Really unfortunate. I think I made a mistake here, though. If a plus b is 0, yeah, oh no, is this okay? If b is 0, then you're left with inches. If a is 0, you're left with this one. No, that's not right, is it? Oh, yeah, it is. Okay. Addition instead of multiplication. 0 number plus inches something is that. Okay. Yeah, you're right. All right. Now, divide. Can't divide numbers by inches. Yeah, well, it's kind of true. I mean, it would make sense, but we're not supporting that kind of inverse inches or anything. All right, so let's see, divide tests. So errors divided by anything is error. Number divided by number, it's always fine. Number divided by inches, okay, except 0. Is that right? Okay, if we take 0 divided by some number of inches, that should be okay. Okay. And then inches, yeah, I don't know, well, let's make a separate test for that. I'm not sure if we do or don't. I think it's going to be value dot, is it nan? Do you get not a number? I thought I had a constant for that. I think we just get not a number because we do the plus infinity, minus infinity. I know we checked that one. I don't know how to generate one. Okay, let's. I'll let it be like this for a moment. Let's check that case. You gonna tell me I can't divide by 0? No. Okay. Yeah, so assuming that ran. Okay, so 0 divided by 2. And then let's number 0. Now, I forget them. I think this one is that plus infinity and this one's not a number, but I think they both should. we're letting it pick that. Number nan. Yeah, because number nans aren't equal. All right, let's save this test. Well, how do I do that test? Let is it let case dot value dot number of value equals this thing. Yeah, I want to do isNan on the result. Welcome back. Okay, so this, I think that's the, no, case label. I could do if let. Number divided by value. Oh, more friend equals that. Then okay, whatever. Then I want to assert true. Value dot is not a number. Yes, and then else I want to say XCT fail and should have found nan. Okay. Okay. Number divided by inches is 0 except 0, so 0 divided by 2 inches is 0. All right. Inches divided by number. If I take 52, well, if I take, I guess I want to check a 0 case here, right? So if I have 0 divided by a number, it's a 0 should be sorry, I'm not quite following double dot nan. You can't compare nan for equality. But I think you can put, you might be able to compare plus infinity. I'm not sure, but you definitely can't do not a number. All right, so I think this should be number 0. Okay, so you get a 0 inches should just be a 0. Okay, so that should be okay. Inches divided by inches is number, so they're going to follow the same thing. It would be 0 anyway. Okay, so I think that's our cases. Okay, so number divided by inches is 0 except 0. Oh, yeah, but I think, well, yeah, that might be a little shorter, wouldn't it? this. Well, I have to. You know, I'm going to leave it the other way. Because I'd have to dig out a formatter and all that stuff to make it come out. Yeah, maybe that might be a little better. Yeah, no, it's worse. I'd probably do it that way. I mean, I still could if I just printed it. You know, it's going to come up with value dot number or something. Yeah, actually test is nan. Yeah, the bad thing is I got to peel out. I got to peel the value out. That's kind of the hard part with these enums. I like them, but yeah, I don't know if I'd write that just to get this is nan out of there. I don't think they have anything like that, do they? Assert no. No. I think I'll leave it there. If it's just for that one case, I don't think I could quite justify that. All right. Here's this number by inches. All right. So let's look at that. Divide number by inches. Well, if we'll put let's on this. If a is 0, we're going to return number 0. All right, inches divided by number. Okay, so that's the other case. Inches divided by number. If a 0. Yeah. Yeah, if there were 2 or 3, maybe I'd go that far. It'd be reasonable enough question sometimes. Okay. I think we've covered the cases for these things. So let's just run a little manual test. I just want to see it work. Plus 3 minus 3 parens equals 5 inches. So this 3 minus 3 went away. A little spacing might be nice in there. I don't know. He's got spacing after. I'll leave that for a future thing. All right, but at any rate, we at least have the 0 stuff working here. All right, so now handle 0 mixed with units. Yeah. All right, m plus m minus shouldn't mix numbers and units. Yeah. I think that works already. 7 memory plus, okay, 44 inches plus memory recall equals error. Okay, 7 inches oops, very clear. I'm not. Because I'm focused on kilt makers, they don't do square inches for things. Everything's like, how long is a pleat and how long around your waist and how long, from your waist to your knees or whatever. So yeah, I'm leaving those out. At one point, I don't know, a couple of years ago, I started a physics calculator kind of thing with, all the, meters and seconds and all that stuff on there. And, there, the powers were important. Yeah. Quilt makers. My wife is both a quilt maker and a kilt maker, and it's easy to get those squished together. They could do something like that because there's a lot of variety for them. So one of their things might be, I've got a quilt that's done to a certain level, and then I want to put a border on it. And lots of times they put multiple borders. So I'll put a 2-inch border and then a 3-inch border and a 1-inch border, or 2 inches on the sides and 1 inch on the top, and those kind of things. And maybe at the end you want to know, I've got a I don't know what size it would be, 80 inches by 80 inches or whatever it would be. I guess you care about those dimensions more. Yeah, they're still probably not doing square dimensions for that. I mean, you could, but your goal is to kind of fill it horizontally and vertically and horizontally. And so you're usually working in the dimensions, in linear dimensions for which end you're doing, so I might have to make my squares a little long if the pattern is, the end result is just that much longer. But I don't usually say, oh, this thing needs to be 6,400 square inches. So, how can I do that? Okay. But in any case, plus memory recall equals, yeah. Yeah. So I think, that's actually done. I'll say already worked. Today. And then memory with units. Yeah, I think what we did made that work. Let's clear this. Okay, so let's say we got 10 inches memory plus. Okay, I guess we got to check the memory part with it. Maybe I didn't do that. 7 memory plus should be an error, right? And it's not. Okay, I guess that's the case you were really talking about. Yeah, okay. It's okay on the outside. Okay. But let me check this one. Might work as is. I don't think we do memory clear. I'm not sure. 7 inches memory plus, and then 44 inches plus memory recall. Okay, that's good. All right, so that's the one we're getting for free. Good. Okay. Because we did the zero stuff, it would break otherwise. Dimensional analysis calculator. Yeah, that's that I started down that path. Not for this one, but for that old project. It's like everything was products. I think there were products of, meters, seconds, whatever, grams, to each one to a particular power. So you could have, grams squared times meter to the -1 or something, whatever kind of stuff you do in physics, But yeah, I mean, it's kind of a neat thing, just user interface on it. You need a few more units than this thing has. So it gets gets tricky. But I think there's neat math in there. Yeah, I don't know. Do you ever see grams squared? You see seconds squared all the time. You got meters squared. You know, it's multidimensional mass for the masses, right? Okay. Memory plus. Yeah. So let's figure out how to make an error there. Well, the question is, where's that error going? I bet it exists. I don't know if we would see it. Let's turn this on. Oh, nuts. So let's clear it all. Memory recall, 7 inches. Okay. Clear that. 44 plus. No. 44 memory plus. Did you complain? No. Okay. Where's that happening? I guess it's in the calculator. Memory add. Oh, we don't have memory subtract yet, so that's worth doing. Memory equals memory plus result. Why did that not become an error? Is it? Let's see. We hit equals. So we did say M plus is like hitting equals and storing it. Okay. But what's going on here? All right. So let's clear. I don't think I get memory clear. Memory recall. Oh, I do. Okay. So 7 inches. Ooh. Let's clear. 7 inches. It's 0, so this is fine. Okay, we'll continue this one. And then if you did 11 and plus, all right, let's print memory. 7 inches, okay, and result 11. Can I do that? Yeah, that's what I would expect. So if I do a step over, memory is the error. Okay, so that we got it there. But the result, yeah, so it's more of a display issue. Huh. Okay, let's turn that off. I think we can make it look weird. Okay, memory recall, error mixing. Yeah, so it's a delayed thing. Okay, so 7 inches memory plus, 11 memory plus, 4 plus memory recall. Uh-huh. Yeah, exactly. Okay. Well, let's see. Yeah, I mean, yeah. Right. It's almost more the fault. Well, assuming your memory is a running thing, it's almost more your fault for trying to put something incompatible in. Yeah. Right. And the memory handling is, well, what crossed my mind was, what if you had number memory and unit memory, but I don't think I want to go that way. I think what I want to do is more like what you said. Yeah, so I need to restart my computation, and we have another to do item was putting an error, separating out the error field, and so you could keep going. And I think that would be a useful thing. So I think what's going on in that calculator here, I think it should calculate this, and if it's an error, it shouldn't put it in, like you're saying. So let's write a test. I don't know if we'll finish this in 10 minutes or not, but okay, memory result. All right, I think we can, this test should be active again now. Calculator memory. I don't know if that is. Did we get that? I can't assign to memory. Okay. All right. Hold on to show the errors. Yeah. I mean, I think that's a little clunky too, as it is. Let's see. That's in display. So display tries to decide if there's no input. Sorry, if there is input, unprocessed input, show that, and otherwise show the result. I guess I'm wondering if an error. Yeah, yeah. I mean, maybe this is the moment to deal with that way and just print the error message. Yeah, just provide a space for that. Somewhere on this. I mean, it's kind of full here. That text is really kind of big. So we're saying, put something here or pop up something even. And the nice thing is it would let you keep editing, so you'd have a separate message. You could dismiss it and then go back and adjust. Yeah, maybe a sheet kind of thing. Dismiss it and then deal with the deleting until you get it right. Let's see. I don't know if I want a. Well, maybe that would be best. I mean, I think some of them are different. Like the computation. If you get not a number, that's kind of a legitimate computation. Okay, now. I'm already weak on my accessibility here. Push it over the edge. Okay, so if we said, no, there's really a separate error field, and if you do something like that one, then we're going to put some stuff in it. That seems decent. Yeah, so I guess what we're saying is published private set var error message starts off empty. And then I guess it would be the job of the banner or sheet or whatever to reset that when it goes away. All right, let's figure out the test. That's probably good enough for... Okay, so down here, memory and result. Okay, so this one is... okay, you push 9 into memory, you do 7 inches, push it to memory, and we expect I don't know, I think our message was can't mix numbers and units or something like that, right? So 9, push it into memory, 7 inches, well, add it to memory, 7 inches, add it to memory. This was the memory. We want to keep the memory the same and leave the error up in our screen. I don't know, this, we almost want to pull a separate field out or something for it. Expect, we got 0, 1. Oh, yes, thank you. Okay. I don't know if I want to pay for the third field here. I guess we can try it real quick here. Some of this we may change our mind about where these errors should go. I want to learn your memory tricks. Yeah, that's a good question too. I don't think it necessarily has to go in history that you had this mistaken thing. But we'll consider that one. Okay, so now I've got 1, 2, and 3. And, or 0, 1, and 2, I guess. This is memory. Okay, and expect that 2. Right, so let's see how this goes. And I don't want to lose that question of history, so how do error messages interact with history? Okay, I got more things failing than I expected. 3 is not equal to empty. Well, now, wait a minute. How... I'm saying memory result error message 0, 1, 2 Memory result should not change. Okay. Well, I guess I'm going to go a couple more minutes to hope you could stay along a minute or two. Yeah, let's do that. Let's clean these. Do that. All right. Run that again. Yeah, it feels like maybe it got error message instead of result. Sorry, where are you seeing that error message instead of result? Error message equal calc.error message. In the assert. Oh, thank you. Hoisted by copy and paste again. I'm really expecting the last case to fail, not all of them. Okay, that's what that looks like. And of course it does, because well, the messaging is a little weird. Let's do that. I just want a very clean failure. Okay, error message is not blank. I don't know why they're coming out backwards to that. 7 inches is not equal to empty. Well, actually, that should probably still be 7 inches. Okay. And error mixing number. Yeah, okay. That's more like it, I think. Should be 2 failures. Okay. All right. Well, we'll pick up there. So tomorrow, 2 to 4:30 Eastern or 6 to 8:30 p.m. UTC. I'm confident we'll fix and finish with the error detection on this memory plus thing, and then we'll add memory minus, and I believe we'll wrap this thing up tomorrow. I'd hoped to today, but that's the way it goes. All right. Thanks for joining Mudshark666, Mighty Coffee Mug, and anybody that didn't speak up. And hopefully I'll see you tomorrow or some other time. And yes, thank you all. All right. Take care. Bye-bye.